Hey guys, this is 2.4. 2.4 uses the word like, unlike, and equivalent. Like and unlike are actually super simple. They're on the very back. And like fractions have the same denominator. Unlike fractions have different denominators. Yeah. So on the back, like fractions have the same denominator. Unlike fractions have different denominators. So if that's a homework problem, look at their bottoms. If the bottoms are the same, they're like. If they're different, they're unlike. Okay. Now for equivalent fractions. Equivalent fractions look different on the bottom and the top. Like 1/2, an equivalent is 2/4. An equivalent is 3/6. And all those bottoms and tops are different from each other. The reason they're called equivalent is because they represent the same amount of something, or the same amount of a shape, which is 1/2. It's just their numbers are different. Okay, well, let's see how you get to those numbers. Well, let's see. If we look at this number 1, it says 2/5 and something over 10 are equal fractions because they have those equal signs. Well, let's think about this. How do we get from 5 to 10? We multiply by 2, right? Okay, well, let's do the same thing. Multiply by 2 on the top. So on the bottom, 5 times 2 is 10. On the top, 2 times 2 is 4. So these are equivalent fractions. Or I could try again and I could say, okay, how do I get from 5 to 15? I times by 3. So how do I get from the top 2 to my new number? I times by 3. So 2 times 3 is 6. Yay, and those are equivalent fractions. Let's look at maybe number 4. How do we get from 6 to 24? What do we have to multiply by? You have to multiply by 4. So 6 times 4 is 24. So what am I going to put in the top box? I'm going to multiply it by 4. 1 times 4 is 4. Okay, now let's look at how do we get from that original 6 on the bottom to this 30? What do you have to multiply by? 6 times who gives you 30? Oh, 5. Okay, so we have to multiply by 5. The original 1 times 5 is 5/30. So 1/6, 4/24, 5/30, those are all equal fractions or equivalent fractions. And you get them by multiplying the top and the bottom by the same thing. So let's look at this very bottom sucker, number 6. How do we get from a 4 to a 24? You multiply by 6. So for the top, to get from 1 to the next box, we'd multiply by 6. Okay. Now let's look at how do we get to this 40 if we start at the 4. If we start at the 4, to get to the 40, you have to multiply by 10. Okay. So that means the 1 on top, to get to the new box, I have to multiply by 10. 1 times 10 is 10. Woohoo! Okay, so all of these are equivalent fractions, and we got them by getting bigger. We got bigger. We multiplied. We got bigger. Okay, now we're going to come up with some more equal fractions, but we're going to do it by getting lower, lower. And instead of multiplying by something, we're going to be dividing by something. So equivalent fractions can be bigger or smaller. They just have to be bigger or smaller by the same amount. Okay, let's look at this 2/4. The fancy words that you're going to see in your homework are the words reduce or the words lowest terms. And that means the same thing. Get an equivalent fraction. And instead of multiplying to get those numbers, we're going to divide to get those numbers. Okay, so let's look at this first fraction, 2 and 4. What can we divide those by? Can we divide both the 2 and the 4 by 7 or 3 or 8? Nah, you can divide them by 2. So let's do it. If I divide that by 2, let's see, 2 divided by 2 is 1 on top. On the bottom, 4 divided by 2 is 2. Okay, let's look at the next sucker. Oh, and my bad, that's lowest terms, or we reduced it. How exciting. Okay, let's look at the next sucker. What can we divide by? Well, we can definitely divide by 2 because they're both even. So let's try that just for kicks. Okay, if I divide by 2, I get 9 over 10. Okay, let's see if you can divide by anything else. And you cannot, because the only thing that divides into 9 is a bunch of 3s. The only thing that divides into 10 is like 5s and 2s. So we can't go any further on that one. Okay, let's look at this next one. 3 over 30. What can you divide by, do you think? Probably a 3, because there's 3s in both. Okay, so let's see what we equal. On the top, 3 divided by 3 is 1 over, on the bottom, 30 divided by 3 is 10. Woohoo! Okay, keep going. The one underneath it, what can you divide those by? Not 2, because the 45 is not even. Darn. I cannot divide by 10 because that 45 does not have a 0 on it. Darn. But both of these numbers have a 0 and a 5. So let's try dividing by 5. Because our divisibility rules say if the last number is a 0 or a 5, you can divide by 5. Okay, well, let's divide. That makes 10 divided by 5 is 2. 45 divided by 5 is 9. Ooh, this might be difficult on your test if you don't have a calculator. And if you're not that great at multiplication facts. Okay, let's look at 5 over 15. What can you divide those by? Definitely 5. And when we divide by 5 on the top, you still have to have a number. So what number can I put on top? What's 5 divided by 5? 1. Okay, then 15 divided by 5 is 3. Woohoo! Okay, if you want to try these next ones, this 14 over 24, if you want to know, it'll be 7 over 12. The next will be 1 over 10. The next will be 1 over 3. And the last one will be 9 over 10. So if you want to practice these, you can by yourself. Okay, I think the next thing we're going to do is what we just did, where we're trying to go lower, but we're going to go lower with freakishly big numbers. Okay, so this is what your homework looks like. It says write the fraction in lowest terms. Well, let's see here. I know it's even, so you can divide them by 2. Let's go ahead and divide them by 2. See what we get. Okay, well, 44 divided by 2, that goes in evenly. 2 goes into 4 twice. 2 goes into 4 exactly twice. Okay, so the top is going to be 22. On the bottom, let's see, 2 divides into 374. 2 goes into 3 once, and when you subtract down, you get 7 17 once you bring down your 7. 2 goes into 17 8 times to make 16. And we subtract down. And you get 1, bring down the 4. 2 goes into 14 7 times. And then 7 times 2 is 14. Subtract down, we get a 0. Hot dog. So 2 and 187 are factors. So we divided that bottom by 2 and we got 187. Okay. Now, let's see. What else could I possibly divide by? Well, what are the factors of 22? The only thing that multiplies to 22 is 2 and 11. Okay? Well, can 2 go into 187? Nope. But maybe 11 can. Let's try. So we're trying to make this as small as possible. And the only thing that goes into 22 is a 2 and an 11. Well, I know I'm not going to use 2 again because this 187 is prime. So let's try and use 11. So 187 divided by 11. 11 goes into 18 once to make 11. And then we subtract down and we get 77. And 11 goes into 77 7 times to get 77. And then we subtract down, we get a 0. Yay. So the point is 187 divided by 11 is 17. And then on the top, this 22 divided by 11 is 2. So, hey, there's our lowest terms. And we know it's our lowest terms when there's nothing else in common. So, I cannot divide 17 by 2. So that means I know I can stop. Okay, let's look at this next sucker. I got a 96 and a 252. So I think I'm going to do by 2 to start with. Okay, so 252 divided by 2. 2 goes into 2 once. Subtract down. Bring down your next number, 5. 2 goes into 2 twice. Sorry, 2 goes into 4 twice. Sorry, 2 goes into 5. Gosh, what's wrong with my face? Okay, 2 goes into 5 twice to get a 4. And we subtract down and you get 1 and then bring down the next number, 2. Okay, 2 goes into 12 6 times. Okay. I think we also need, so we just found 252 divided by 2 is 126. Woohoo! But now I need to do 96 divided by 2. Okay, let's do 96 divided by 2. 2 goes into 9 times 4 to get you an 8. And we subtract down, bring down your next number. 2 goes into 16 8 times. Okay, so we divided by 2 and we got 48 over 126. But you can probably go by 2 again. Yeah, if I do 2 again, I get divide 48 by 2, and that should get 24. Then divide 126 by 2, and that should give you 63. Okay? And then think about what goes into 24 and 63 and see if there's anything in common. I think what's in common is a 3. So let's see here. 24 divided by 3 is 8. 63 divided by 3 is 3 goes into 6 twice, evenly. 3 goes into 3 once, evenly. So 3 times 21 is 63. So we were supposed to take 63 and divide it by 3, so it's 21. And then you ask yourself, okay, is there anything else in common? Well, the only thing that divides into 8 is a bunch of 4 and 2s. And that never goes into 21, because 21's odd. So you're done with that problem. Yay. Okay. This next sucker says, in each row, circle the fractions that are equal. Okay. Well, let's find something with a 1 in it. Okay, so this 1 over 5, what's his equivalent? Well, if I multiply this by 2, let's see. 1 times 2 is 2. 5 times 2 is 10. Hey, 2 over 8 is an equivalent. Yay. Okay. What about if I multiply by 3? So to get from 1 over 5 to 2 over 10, you multiplied by 2. Now let's multiply by 3. If I multiply by 3, let's see where it gets you. So 1 times 3 is 3, so it's one of these two suckers. All over 5 times 3 is 15. Yeah. Okay. And then if we multiplied by 4, we'd see 1 times 4 is 4, and 5 times 4 is 20. And that's not what I have right here. Okay, so all 3 of these are equivalent fractions. Okay, let's look at the next row. We don't really have anything else to go on, except for this 3 over 5. Okay, let's see. If I take this 3 over 5 and multiply it by 2, what do we get? You get a 6 over 10. Do we have that here? Nope. Darn. What about if I multiplied by 3? Okay, well, 3 times 3 is 9. 5 times 3 is 15. Do I have a 9 over 15? No, I don't. So this is out. Okay, let's look at this 2 over 7 and see if I can multiply him to get the other stuff. Okay, let's multiply 2 over 7 by 2 over 2. 2 times 2 is 4. 7 times 2 is 14. Let's see if we have that. Nope, I don't. Darn. Okay, well, let's try multiplying by 3. 2 times 3 is 6. 7 times 3 is 21. Okay, do we have one of those? Yes, we do. So these two suckers are definitely equivalent. Let's maybe try multiplying by 4. Okay, if I take this 2 over 7 and I multiply it by 4, 2 times 4 is 8, which is what we have over here. 7 times 4 is 28. Oh, which is what we have right. Okay. So these 3 were equivalent fractions. Okay, let's look on the bottom. We'll start with this 3 over 5. Let's multiply 3 over 5 by 2. What do we get? 3 times 2 is 6. 5 times 2 is 10. Hey, look at that. It's right here. So 3 over 5 and 6 over 10 are equivalent fractions. Okay, let's try multiplying by 3 now. Because to get from 3 over 5 to 6 over 10, we multiplied by 2. But let's try multiplying by 3 now. So 3 times 3 is 9. 5 times 3 is 15. So do we have a 9 over 15? Hot dog, we do. Yes. Okay, now let's try multiplying by 4. 3 times 4 is 12. 5 times 4 is 20. And we don't have that, because these last two suckers are 24 and 18. So the only 3 equivalent fractions are these 3 right here. Okay, so again, equivalent fractions or lowest terms mean that the fractions are equal to each other. They came from the same numbers, only you have to multiply up or divide down. to get equal fractions. Okay, and then again, at the very end, it says like and unlike fractions. Like fractions have the same bottom. Unlike fractions have bottoms that are different. 4, 2, 3.